Welcome to APCV 320 Computational Thinking and Doing, and we are finally getting to Python. Lecture slides were adopted from Professor Henry Worshan, Applied Computing and Computer Science Program Director, who taught this class during the fall semester of 2020. So this is a bit of an overview of what we are going to be covering here in this lecture. We will cover all the topics here in the next hour or so. And this goes in conjunction of what we covered in the algorithms lecture, as those two pieces go together so you can tackle the programming with Python assignments. Okay, so let's get right into it. An expression is a combination of values, variables, operators, and calls to functions. An expression in Python could be a single data value or a combination of data values, variables, operators, and function calls. Expressions in Python programs must be evaluated. For example, if you have the expression, you have a parenthesis 1 plus 4 times 3, you close the parenthesis in your program, Python will evaluate this expression as 13, meaning it's going to do the multiplication first and then it's going to do the addition. So it's going to be 4 times 3 is going to be 12, 12 plus 1, final answer would be 13. Python supports several operators, including arithmetic operators, relational operators, and logical operators. We will cover relational operators and logical operators later in this course. Some of the arithmetic operators supported by Python, including addition, subtraction, multiplication, division, remainder, and exponentiation operator. Now, so in Python, you can compose expressions by combining the different kinds of operators and into the expression. When more than one operator appears in an expression, the order of evaluation depends on the rules of precedence. Python follows the same precedence rules for mathematical arithmetic operators that mathematics does. Parentheses have the highest precedence and can be used to force an expression to evaluate in the order you want. You can use parentheses to make an expression easier to read. For example, you can say like parentheses minute times 100, you close the parentheses divided by 60, even though it doesn't change the result, but you can do it directly. You could say also like minute times 100 divided by 60 as well, and you'll get the same result. Exponentiation have the next highest precedence. Multiplication and division have the same precedence, which is higher than addition and subtraction, which have the same precedence. So for example, if you have this expression coded in your Python program, and Python will evaluate 3 times 4 first, since multiplication has higher precedence than addition. Operators with the same precedence except for exponentiation are evaluated from left to right. In algebra, we say they are left associative. So 1 minus 4 will happen first, and the result is -3. Then -3 will be added to 4 with a result of 1. Exponentiation in Python and mathematics is right associative. So when evaluating the expression 2 of power 3 of power 2, instead of evaluating from left to right, the expression will be evaluated from right to left. So that is 3 to the power of 2 will be added to the first results, will be 9, and then 2 to the power of 9 will be evaluated next with a result of 512. Keep in mind, dividing by 0 crashes the program. Integer division uses the token /. It always truncates its results down to the next smallest integer. For example, we call it the quotient, or the value to the left of the decimal point. The modulus, or remainder, it's an operator which is a percent sign, yields the remainder when the first operand is divided by the second. For example, 14 is divisible by 4 3 times with a remainder of 2. 218 is divisible by 5 43 times with a remainder of 3. Okay, so in addition to integer math, obviously Python is able to work with real numbers, Of course, a real number is not an integer, it's a variable with a decimal point. The normal operators are plus, minus, multiplication, division, the modulus, and the exponential work. So take the example of the real number 15.0 divided by 2.0. The answer is a real number 7.5. The same rule of a precedence left to right also apply to real numbers. So you start with basically evaluating anything between two brackets before you do the multiplication or the division or the percentage, and also before you do the plus or the minus in the equation. Another thing to note, when mixing integers with real numbers in math, the result will be a real number. The example there, 1 divided by 2.0 is 0.5. 1 is integer divided by a float of 2.0 as a real number, and you get a float of 0.5. And also in the associativity with the last example, note the mixing of integers with real numbers. It's done left to right. 3 goes into 7 two times and you throw away the remainder. Same goes with 2 that goes to 1 time into 3 and you throw away the remainder, and then you multiply 2 by 1.2 to get 2.4, and you add that to 1 to get 3.4. Math commands. A module is a file containing Python definitions and statements intended for use in other Python programs. There are many Python modules that come with Python as part of the standard library. Some modules introduced in the interactive book include Math, Turtle, and Random. To find out information on the standard modules available with Python, you should go to the Python documentation site to check. For your first programming assignment, you will use the Turtle module quite extensively. I will not be addressing the Turtle module's functionality, so make sure you check the textbook chapters to approach your assignment. How to use a module? First, you import the module or functionalities in the module. Once imported into a program, we can use things that are defined inside the module. In this example, an important statement is used to load a module named Math. That module contains math functionalities we can use. For example, we can use the ceiling function based on the dot notation. The dot notation means the ceil function defined within the math module. If you use the second way to import all functions from the math module, you can use the ceil function directly in your program. This slide addresses all Python modules. So if you are interested in knowing more about other modules used within Python, you just type help modules and it brings all the modules that you really see in this slide. So this is some of them I'm showing here, but I highlighted two important modules, which is Turtle and Math, and those are going to be used extensively in doing your assignment and homeworks moving forward. So just pay attention to that, please. Directory command in Python allows you to see the associated functions for each module. So for example, here we look at the math directory and it shows its associated functions, and you see like a bunch of them here. So for example, you will be able to use math.str, for math.string, for example. We do the same thing for directory turtle module. It's a good module from an educational standpoint to teach Python. So it's a very good way to start, but it's actually geared more towards school children to get something spontaneous and interactive. But look at the number of functions are available once you import the Turtle module. You will be using a subset of these functions for your programming assignment. The previous slide shows the functions associated with Turtle module. In the example here, if you have a question on particular function, you use the Python help command, typing the module name first, then dot, then the particular function, which happens to be circle here. And it returns detailed explanation of what circle function within Turtle module does, along with examples on how to use it. Obviously, all this documentation is available online, and it's also installed inside Python interpreter, so you can look it up. We use variables in a program to remember things like the current score at the football game or somebody's age. The values stored in variables can change over time. You can assign a value to a variable and later assign a different value to the same variable. The evaluation of an expression produces a value, which is why expressions can appear on the right-hand side of assignment statements. A value all by itself is a simple expression, and so is a variable. Evaluating a variable gives the value that the variable refers to. So in this example, like we put the value of x equal 5 and the GPA equals 3.74. So if you look at the bottom example where it says x plus 4 equal 9, it means that the value of x that was assigned originally as 5 is going to be added to the 4, and the result would be stored as 9. One other important concept is the ability to output from the program to the console screen. If you ask Python to print an expression, the interpreter evaluates the expression and displays the result. Len or len is a built-in Python function that returns the number of characters in a string. So if you look at the where it says message equal hello, comma, space, word, and the exclamation mark at the end, if you add up all these ones, they will come up to be 13. The input function allows the user to provide an input value. When the function is evaluated, the prompt is shown. The user can enter a value for the variable and press return. The value of the variable can then be used in the program. Note that the value input, even though is a number, is stored as a text string. In order to use the value as a number, you have to do a type conversion, which we will cover later in this lecture, but basically is passing the input text string to the int or float function. The range function is used to specify a range of integers. The format is using two mandatory parameters. The first parameter indicates the start point of the generated sequence of integers. The second parameter is used to indicate the ending point on the sequence of integers. The ending point is not included in the generator of the sequence. Optionally, a step value, positive or negative integer, can be specified as a third parameter to the range function. So let's combine the range function with a for loop statement. So now we will visit a concept that we just covered quite extensively in the algorithms, and that's the for loop. The idea is a for and a variable name in a group of values and the statements. So for each iteration to the for loop, the variable name will take the value of the array of the group of values. So the example there is combining the for loop with the range statement. So if you look at the example, it says print x square x, and it's going to be x times x. So you start with the range, obviously it's going to be 6 minus 1, which is 5. So we're going to start with value number 1, which is going to be the first value in the range, which is 1. 1 squared is going to be 1, and then it's going to go to the next value, which is 2. 2 squared would be 4, and then the 3 squared would be 9. 4 squared would be 16, and 5 squared would be 25. And obviously there will be no 6 squared because the range is 6 minus 1, which is 5. A binary if-else selection statement provides the ability to check conditions and change the behavior of the program accordingly. Selection statements, sometimes also referred to as conditional statements, providing this capability. The simplest form of selection is the statement. This is sometimes referred to as a binary selection since there are two possible paths for execution. The statements for each branch could be a block that contains a sequence of statements. Each statement could be any valid statement. For example, it could be an assignment statement or another conditional statement or iteration statement. The else if statement allows you to check multiple expressions for a true and execute a block of code as soon as one of the condition evaluates to true. Similar to the else if statement is optional. However, unlike else, for which there can be at most one statement, there can be an arbitrary number of else if statements following an if. This provides the ability to replicate the switch or case statement, which is otherwise missing in core Python. This slide talks about the if statement, which we call it the unary selection statement, which is another form of the if statement, is one in which the else clause is omitted entirely. This creates what is sometimes called unary selection. In this case, when the condition evaluates the true, the statements are executed. Otherwise, the flow of execution continues to the statement after the body of the if. Repeated execution of a sequence of a statement is called iteration. Because iteration is so common, Python provides several language features to make it easier. We've already seen examples of for statement in previous slides. For statements provide a very common form of iteration in Python. The while statement is another way to iterate within a Python program. The while statement provides a much more general mechanism for iterating. Similar to the if statement, it uses a Boolean expression to control the flow of execution. The body of while will be repeated as long as the controlling Boolean expression evaluates to true. Python supports relational operators which evaluate to true or false, or in other words, it's a Boolean expression. Note the use of the double equal equal to test for equivalency, since a single equal is used to assign a value to a variable, and the exclamation in front of the equal negates the value to be not equal. And the rest of the symbols here, or the operators, you have the less than, and then you have the greater than, and then you have the less than or equal, and then the greater than or equal. So if the condition is true, then the end result would be true, otherwise would be false. There are three logical operators: and, or, and not. The semantics or the meaning of these operators is similar to their meaning in English. For example, x is greater than 0 and x is less than 10 is true only if x is greater than 0 and at the same time x is less than 10. So the two conditions have to be met at that point for that statement to be true. And then when you say like n percentage 2 equal 0 or n percentage 3 equal 0 is true if either of the condition is true, because we're using the or. So if one of the condition is met, then the output would be true. So that is if the number is divisible by 2, or if it's divisible by 3, then the output would be true. So in this case, one or the other or both of the parts has to be true for the result to be true. Finally, the not operator negates a Boolean expression. So not x is greater than y is true if x is greater than y is false. That is, if x is less than or equal to y. The input function allows the user to provide a prompt string. When the function is evaluated, the prompt is shown. The user of the program can enter the name and press return. When this happens, the next that has been entered is returned from the input function, and in this case assigned to the variable n. Make sure you run this example a number of times and try some different names in the input box that appears. So let's get into text processing. For loop processes, each character in the string literal in a list. Each character in turn is reassigned to the loop variable and the body of the loop is executed. For loop statements are frequently used to process tests of strings. For example, the for loop on this slide is used to examine each character on the string liter of oil, and during each iteration a character is assigned to the loop variable C, and the loop body, which is composed of only this single statement, is able to print the line held by the local variable, and eventually the output is like this. String concatenation and repetition. String indexing. The indexing operator in Python uses a square of brackets to enclose the index. Select a single character from a string. The characters are accessed by their position or index value. For example, in the string shown, Luther College, the 14 characters are indexed left to right from position 0 to position 13. The positions are also indexed from right to left using negative numbers, where -1 is the rightmost index, and so on. Note that the character at index 6 or -8 is the blank character. This slide talks about strings and numbers. So if you use the command ord and you put text in it, this will convert a string into a number. So for example, if you say ord and you put between quotation mark the A, this means, like the number for that one would be 97 in the ASCII. and then if you do OR for the letter B, it will be 98. So as I said, like this is the characters map of numbers using standardized mapping such as the ASCII or the Unicode. And also you can also convert a number into a string using the char or the CHR. So if you put CHR 99, which you know is going to be C, this will pass as a C letter. Also, you can do a string, and you can it turns it into an integer by using this command, which is the int, and you put text in. So we know that 99 would be C. So if I put 99 between those two quotation marks inside the integer, the output would be 99. And I can do the same thing with the real numbers or the float, where we can say like float text. And in this case, I can say float, and I put between two quotation mark 99.0, and my output would be 99.0. The primary purpose of function is to help us organize the programs into chunks that match how we think about the solution to the problem. Factorial done recursively and iteratively. A function may take 0 or more parameters. It doesn't have to have 2. In this case, the calculation of the factorial function might be specified in the body of the functions based on iterations or recursions. Function definitions can call other functions, such as range in the first definition and fact2 in the second definition. The function is able to return a value using the return statement. So if you use the first one, which is def fact1, and you have the n, and if you substitute the n in the first one with the 6, then you'll end up with a factorial value of 6, which equals to 720. While if you use the second definition, which is def fact2, and you applied that with the value of 200, then you'll get this long string as an answer. Slides 3 through 27 above were adapted from Dr. Lee Zhu and Trent Head, who created them based off Dr. Mary Stepp lectures. So I just wanted to give the credit to the proper people. The following two slides, slides 29 and 30, they address the 4 chapters from the book, How to Think Like a Computer Scientist, Interactive Edition. So on slide 29, as you see, we have chapter 1 and chapter 2, and in chapter 1 it's general introduction, and chapter 2 talks about simple Python data. I encourage everybody to read through those very well, because this will build your knowledge base. As for chapters 3 and 4 on slide 30, you will notice that it talks about debugging interlude, and chapter 4, which is the Python turtle graphics, and this is what you really need to put more time in, because this will help you in accomplishing great results while you are doing your assignment for this module. This slide addresses Python enhancement proposal PEP 8. So a while ago, there was a question asked about if Python assignments should be compatible with PEP 8 standards, and the answer is no. But the more I looked into it, the more it was appropriate to introduce the PEP 8 to you, because it's better as a best practice while learning Python to just start with best practices in place, and nobody would never know the difference versus having to try and add a process later on. Let me be very clear, I'm not an expert on that, so I know it's enough to understand and to follow the guidelines. The guidelines are meant of the maintainability and the readability of your code, and the fact that you might have forgotten things, then you have to go back and update the program sometime later on. Also, somebody else has to come in the future and update a code that you have developed by being really focused on readability. The first thing is the Zen of Python. So if you go to your interpreter and type import this, the console screen returns what you see in the screenshot below. It comes back with a gentleman named Tim Peters representing Python, who basically wrote some design methodology worth some discussions, and they are there to appreciate the readability, which is really the kind of what drives the PEP 8 standards. So anyway, PEP 8, you will see that PEP 8 exists to improve the readability of Python code, helps you collaborate well with others, and makes it easier for them to understand the code you write. This slide talks about how to write a beautiful code with PEP 8. And there is a video on the top. If you click in the link, will take you there and it will give you more info. But the narrative is really worth going through because it shows you the way how you really need to write your code. So again, this slide was organized this way because I was able to find content to reuse. I did add some stuff to get modified by margin or multiple sources together, but would like to name a few matches code layout. The indentation is to be part of code layout, the use of comments, and the use of white space, which includes new line, spaces, tabs, carriage, return, feed, etc. White space is a string that has been pre-initialized and is used as a string constant. White space can set things off and reduce the strain on the reader's eyes. Because the compiler ignores white spaces, you are free to place things anywhere you want and format it however you want. So naming convention. So the guidelines on using title case with no space for class names, function names, usually lowercase with underscores to improve readability. If we just had this function without the underscore, it would have been hard to pick out each individual word, and then of course the idea of constants to keep those in module levels. We talked a little bit about the global versus local use of variables, but the guidelines are to use all caps. It's just really a quick way to differentiate a function versus a class name versus a constant. The self is used to represent the instance of the class. With this keyword, you can access the attributes and methods of the class in Python. It binds the attributes with the given arguments. The reason why we use self is that Python does not use the at syntax to refer to instance attributes. CLS accepts the class person as a parameter than person's object / instance. Now we pass the method person, for example, print age as an argument to the function class method. This converts the method to a class method so that it accepts the first parameter as a class, i.e. person. Also in Python, you will find different names which start and end with the double underscore. They are called as magic. They are called as magic methods or dunder methods. This will lead to the clashes if you use these methods as your variable names, so it's better to stay away from them. Module names are usually mapped to file names, and because some file systems are case insensitive, and it will truncate long names, so it's kind of hard to keep them fairly short. You don't want to be too long with the names, otherwise you will go over limitations, since Windows has a maximum number of characters for fully qualified path names. There is a useful of leading underscore, so you can say the double leading and trailing underscores are for the most part should be reserved. You should not use them too much or use them from the standpoint when you import modules from a standpoint, but the only place in that last example, there is a few. So for instance, class is a reserved Python keyword. So if you needed to use a class from variable context, the idea is to put the underscore at the end of it so you don't conflict it with the Python reserved word, but you are able to give a still meaningful variable name of a class in this example here. So Code layout. Remember, indentation in Python is very important. Indentation should be using spaces, not tabs. The font that's used is the fixed width font with indentation spacing of 5 according to the guidelines. If you use different font, the tab spacing will be different. Notice the other convention. For instance, in the MyList array example, the proper way of closing the bracket is by having it on a new line. In both examples, you won't get an error message. It is just to emphasize the best practices. Spaces are the preferred indentation method as stated previously. The old terminal applications are allowing a maximum of 79 map characters. There is a convention about how you truncate a line to keep it 79 characters. This is to prevent word drop, assuming that Windows size is still 80 characters. Conventions for blank lines. Surround top level function and class definitions with 2 blank lines. Method definitions inside a class are surrounded by a single blank line. Extra blank lines may be used carefully to separate groups of related functions. Blank lines may be omitted between a bunch of related one-liners, so make sure to use blank lines appropriately. Avoiding white space. Do not arbitrarily use white space to properly indent for hierarchy here. In the example above, notice the array of ham with index of 1. Do not put the spaces before and after 1, or again arbitrarily after the 2. Spaces should be discreetly used when necessary, but not added unnecessary. Another example on white space. Again, do not add spaces after the commas or the semicolons. It's not needed to delineate each of the variables from each other. In this white space example, do not add a space immediately before the open parenthesis that starts the argument list of a function call. Doing so might give an error. Yet another example on white space. Do not add a space immediately before the open parenthesis that starts an indexing or slicing, because the index into the list is the variables, so you do not need to space it. Doing so might give an error. And yet another white space example. You do not throw white spaces just to make the equal signs line up. You may think it looks more readable, but it actually gets the X lost there. So use the normal space before and after the assignment equals and do not use extraneous spaces. In this white space example, do not use spaces around the equal sign when used to indicate a keyword argument or a default parameter value. Again, this is beyond the scope of the assignment in hand about the twin turtles movements, but it is good to know the best practices from the beginning. And then the documentation strings. Python doc strings are the string literals that appear right after the definition of a function, method, class, or module. If you have a string that spans multiple lines, then the idea is you start it, but you put the clause using the triple. It's a multi-line documentation string. The multi-line doc string should be on a line by itself. In Python, use the import keyword to make code in one module available in another. Imports in Python are important for structuring your code effectively. Using imports properly will make you more productive, allowing you to reuse code while keeping your projects maintainable. So when you import modules, and again for readability, you import each module on a separate line. This gives better visibility of which module you use when you import them line by line. And this is the context of what I call a fully qualified name. So in the example here, if you are importing and not recognizing those views, and again, if you happen to be within this test app importing a creative view, the idea is to fully qualify that, and there is no ambiguity. When it's fully qualified, it doesn't matter where you do the import from, it's always going to resolve. PEP 8 is the tool to check your Python code against some of the style conventions in PEP 8. It features the following: plugin architecture, which has the adding a new, which makes adding a new checks easy. Parsable output, which means it jumps to error location in your editor. Small, which means you require just one Python file that requires only standard library, which means you can use just the pep8.py file for this purpose, and also it comes with a comprehensive test suite. This is an example of the output that you would get. It will show you where you are missing white space, or the closing bracket does not match visual indentation, or you have a blank line at the end of the file. And again, by running this and staying consistent with PEP 8 guidelines, you are going to maximize the readability of your code for whoever is going to read, digest, and maintain in the future. And another example of some of the other things that you can get by running the PEP 8 checker. So these are the references here. You can read through these for a lot more detail. Again, you are not going to be graded on PEP 8 guidelines, but they are there to show you how to write your code following best practices. So that was a lot to go through and digest. We will revisit many of these concepts later in the course. In the next module, we will focus on programming with Python, so you will be able to identify and practice language elements in Python, and also apply Python control structures and modules to write Python programs.